This is my series on quadratic equations and quadratic functions. We start off with a lesson on the parabola, y equals ax squared. And we're going to look at a equals 1 first, the parent quadratic function, and then we'll look at a few more examples. Check it out. Well, you know what polynomials are now, right? We're doing these things called polynomial functions, and they look like this: y equals, and these have constants in them as well, something x squared plus something x plus something. Like so. And we've got missing numbers here, here, and here. And from chapter 9, that should look familiar. That is a trinomial, isn't it? So we've been factoring trinomials. Now it sort of comes in useful in this chapter. But instead of something, 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 we're actually going to write a, b, c. Y equals ax squared plus bx plus c. And when it's degree 2, we actually don't say polynomial function. We're going to say quadratic function. So when we have y equals, and you've got a polynomial with the degree is 2, so actually a linear function is a polynomial function, isn't it? It's a polynomial function of degree 1. A polynomial function degree 2 is called a quadratic function. Degree 1, it's called a linear function. And today all we're going to do is look at this case, just when we've got x squared or something times x squared. So let's work that out using our first example 1 here. Let's get straight into that. So example 1, we're going to graph something called the parent quadratic function. And the parent quadratic function is the most basic quadratic function we can have. It's just y equals x squared, y equals 1x squared. So if we're thinking like this, we're thinking of the case where a is 1. Now to do this, what I'm going to do is just make a table to start with, because we don't know what the shape's going to be yet, right? It's our first time doing this. To draw this, let's make a table, just like we have been doing up until now with our other functions. And I'm just going to do -3, -2, -1, 0, 1, 2, 3. And we're going to fill these out. We want to know, what are all these values? And let's go through them one at a time. So to work these out, let's not guess. We're going to put it into the formula here, and it's very basic. So if I was going to do, for example, x equals 2, I'm going to get y equals, you put x is 2 into this, y equals 2 squared, which is 4. So that is the point 2, 4. So remember, this is a point here. It's telling us that this function is going to go through the point 2, 4. So let's do that. 1, 2, and 4. 1, 2, 3, 4. You don't have to write the coordinates up here because I can see them here and you're working. If you haven't done a table, I really need to see these points. So that's 2, 4, right? In the first quadrant. Remember your quadrants? First, second, third, fourth. First one here, and it goes counterclockwise, anti-clockwise. And let's do one over here. I might do x equals -3. This is important because of the minuses. Is this right? You tell me. For my working, x equals -3, y equals -3 squared, which is -9. Is that correct? What do you think? The answer is no, that is incorrect, because we are squaring the negative as well. So that's -3 in brackets all squared. And what's that? That is -3 times -3, which is +9. So we have another point, -3, 9, so which is over here somewhere, -3, 9. Say about there. Go ahead and do the rest for me and tell me what you come up with. And done. Hopefully you got these values. So these are all perfect squares, aren't they? 1, 4, 9. And if you did the coordinate plane bigger, the next one would be 4, 16 and -4, 16, right? So let's graph this. Is it a straight line? Obviously not. The points are not lining up, so it's not a linear function. It's not a straight line. It's a curve. That is what we call lines that are not straight. We just call them curves. Oh, 0, 0, I forgot that. Now, it's going to be a U shape, and I'm going to draw it for you right now. U shape, U. I can do it much better on paper, but let me just tell you how not to draw it. This is not right. It It should not be a sharp V shape here. That is not right. And it should also not look like this. So see how at the ends it's going straight up? It should not look like that either. It should just keep going out to the sides. Oh, this is a bit suspicious here. Right, so it keeps going out far left and far right. And oh, that's a bit bumpy there. And another thing, this is definitely not right. It should not curve and come back inside either. Why is that not right? Well, if that was the case, then we couldn't call it a function, could we? Because that would then fail the vertical line test. We would have an x value where we have two different outputs, which is not a function. All right, so do your best. And so quite often in the homework, we're going to be doing more than one of these shapes per question. So make sure you write the equation next to it. Now, just out of curiosity here, domain and range. The domain is all real x. It's going to go on forever on the left and on the right. If I go out to x is 100, I'm always going to have a y value. It'll be huge, but I'll always have a y value. And the range, if I'm looking from the side, what are the outputs? The lowest this goes is y equals 0. Y equals 0 or greater. Y is greater than or equal to 0. That will be the domain and range for this parent quadratic function. Next thing, what is this shape called? It's got a really interesting name. The shape is called a parabola. I think some people say parabola, but the shape is called a parabola. And when it's like this, we say it opens up. Or you could also say it's concave up. And you're going to be doing these all the way up until grade 12. And if it's upside down, which can also happen, which might happen in the next example, we say it opens down. Or it's concave down. B, we have another parabola we're going to graph. It is the parabola y equals -1/2 x squared. So this is one of these as well. It's a equals -1/2. It's the a equals -1/2 case. So it's still y equals ax squared, isn't it? And then we're going to compare it to this one. So one reason we call this the parent quadratic function is we compare all other parabolas to that one. It's like the most basic one we can have. So to graph this one, let's do another table again. So y equals -1/2 x squared. X, y, let's do the same values here. -3, -2, -1, 0, 1, 2, and 3. Again, I'll do a couple of examples for you to get the numbers. But what do you think is going to happen? Is it going to open up or is it going to open down? What do you think from what I was just telling you? Let me do x equals -2 for you. X equals -2. Put it into this formula. Y equals -1/2 times -2 squared. Now again, remember the -2 is getting squared, so that should be brackets here. And now it's a PEMDAS problem. So we do our exponent first, -1/2. -2 squared, the negative is getting squared, so it becomes +4, which is -2. So this is -2, -2. Remember, that's a point. It's telling us the point. -2, -2. I might change colors here. I'll do green. -2, -2. You don't have to change colors, by the way. Another one, let's do over here. 3, x is 3. So where can I do my work? I'll do my working down here. X equals 3, so y equals -1/2 times 3 squared. -1/2 times 9, which is -9/2, which is -4.5. Mixed numbers better. We can sort of see where it is on that compared to whole numbers, can't we? So 3 is 3, -4.5. And where is that? 1, 2, 3, -4.5. I think it's about there. Oh, what am I doing? I should be doing green. And it's about there. Okay, go ahead and do the rest for me. And you should get these numbers here. And you know what? I think the next number might even fit. What if I did x equals 4? What would that be? That would be 4 squared times 16. 16 times -1/2 is -8. Oh, that would also fit. So 4, -8. 4, -8 will be down here. And also on the other side, -4, -8 will mirror over there. And that's our points for the second one. So let's draw that in. Nice and smooth, going out wider, and it should not be a sharp corner here. It's just a smooth U shape. Okay, that's better than my first one. Y equals -1/2 x squared. There we go. So what's the difference there? You can see that this one opens down and this one opens up. And the question says compare. So to compare, I'm just going to say compare. You basically talk about two things when you're comparing. Is there a flip? Is there some sort of shift, like a flip or a shift? So what I'm going to do is draw another line here. X equals 2, just for instance here. How high is this? This is 4 units high, right? And how low does it go? It goes down 2. So can you see that the blue one is sort of higher and the green one's kind of shrunk down a little bit like that? So we say vertically it's been shrunk or stretched. So this has been vertically stretched and it's been flipped. So what I'm going to say for our compare is, it's a vertical flip. You could also say, talk about the concavity, or it opens up and opens down as well. So you could say that the second parabola is the first one opening down, and also it's a vertical shrink, okay? Compared to the blue one, the green one's been shrunk closer to the x-axis, hasn't it? So that's what we say for compare. I'm going to look at this when you can actually use an animation and move it manually, okay? So let's just take a quick look at that. So just open your browser and type in Desmos, D-E-S-M-O-S. So you click on Start Graphing, and then this comes up. And what I like to do is you click on the wrench or the spanner, whatever you like to call that. And I usually change this to step 1, step 1. Okay, just so each unit, I think without doing that, it's like 2, 4, 6, 8, only the even numbers on the axis show. But if you do 1, 1, then all the numbers show. And then I click on minor grid lines, uncheck that box, and then just click into the white space, and it's nice like that. So there's your coordinate plane. Now let's type in that parabola y equals x squared. X caret symbol squared. There it is. There's the parabola y equals x squared. So that's the first one we did in the lesson. The standard parent parabola, I guess you can call it, opens up, or it's concave up. And you can put in like a minus there, and it makes it open down or makes it concave down. What I'm going to do is put in an A there. And then it says add slider for A, and then you click A, and look at this. You can just move this manually. Okay, when A gets larger than 1, it gets skinnier, doesn't it? And you can also change the window here. You can pinch in, pinch out. And when you make A smaller, a number less than 1, it gets really... So A equals 1 is kind of like the standard parabola. It goes through 0, 0, 1, 1, 2, 4. And if you followed that up, that would go through 3, 9, and then 4, 16, so on and so forth. When A gets less than 1, between 0 and 1, it gets fatter and fatter. And when A becomes 0, we get the line y equals 0, which is the x-axis, isn't it? And then if A becomes negative, it flips. Goes down like so. And when A is between 0 and -1, it's fat and upside down. And when A is -1, okay, you've got that standard 1, -1, 2, -4 parabola going down. And then when you make A really big and negative, it gets skinnier, opening down like so. So one thing you can notice here is that it's always through the point 1A, I guess you could say. Just wondering if you can type in a point here, 1, A. And then you can see that, and you can label that there like that. It's quite cool, Desmos. And now what happens if you change A? The A value is always the y coordinate of this point. And that will also always trace like that. So this is Desmos, everyone. It's quite fun. You won't have access to this in a test or anything like that, but it helps give you a good visualization of what's happening. So have a little play with that. So there you go. Desmos is kind of cool, right? So just in summing up, today we're doing quadratic functions. The basic quadratic function, y equals something times x squared. When a is positive, like this one, it opens up, and in this case, a is actually what? This is a equals 1, okay, there's a 1 there. And down here we have a value is -1/2, and when a is negative, it opens down.